Hello guys. We are going to start chapter 3. In this chapter we are going to introduce various blocks and their applications in Simulink. In this chapter, first we want to have a definition of block in Simulink and its application. Then we want to explain make changes on blocks information, such as enter the values of the blocks in for different variables. Then we have priority of blocks during the simulation, because in complex systems there are lots of blocks. The Simulink prioritize the blocks in the simulation. So it is very important for you, if you want to have complex projects and simulation, then we have want to explain make changes on the blocks shape. It means how we can change the shapes of blocks, or even I want to explain you how to copy the blocks. Then we want to explain you the different blocks and important libraries in Simulink. There are 4 important libraries which here I want to explain them. First one is commonly used section blocks. That most important blocks will be explained. Also, I will give an example for each one to understand it easily. Some blocks are, for example, here product, sum, gain, switch, bus and mux, and logical operation, or even some other blocks. But pay attention that here I won't explain all of the blocks, because in the next sections and next episodes we will learn other blocks and I will explain them there. Then I want to introduce you the continuous section blocks. There are some blocks, derivative, integral, transport delay, transform, function, that it has lots of applications. Also, then most often to introduce discontinuous section blocks, such as saturation. As you know, most of the systems that you simulate are nonlinear. So, and in nonlinear there are lots of states that one of them may be saturation. Then we have dead zone, we have rate limiter, we have relay that will work as some industries use, and we have heat crossing that gives some pulse to the system. And there are some blocks that will be explained. One of the most important part is the sources section. As you know, in any section that you want to simulate, you should have input in order to get the output. This part we will explain to you. In block, ground, from file, from workspace, signal, generator, white noise, pulse generator, and most of the blocks that are here. So I will explain them by an example too. The reason that I simulate each block is that I want to tell you that how to use it in the real world and how to use it in your simulation, and you can understand it easily. I want to explain here sync section blocks. It is very important because you want to display your blocks, so you need sync section blocks. There are some blocks here I will explain: terminator, to fall towards place, floating, scope, which equals 1 and works, floating and doesn't need signal. And then we have x, y graph.